it can be referred to as a building, and each parking lot is a real-life parking lot, and they are connected by a short process link. Here is another input called trip table, which is the OD matrix. Another file called trip time, and we are going to see what it is. And these are the outputs. So very simple. So I just copied the output, link, activity location, and process links to the input of convert trips. I have overwritten all of them. And here's a new file I created called trip table. You remember we created 4 zones, and this trip table is just defining the trips between these zones. So for example, there are 100 trips from zone 1 to zone 2, 100 trips from zone 2 to zone 1, and likewise. I already mentioned Transits does not use zonal trips, but in our metropolitan planning agencies, organizations, they still have a lot of OD trip tables, OD matrices. And this step, I'm going to show you how to convert this OD table or trip table into the format that Transits requires. So we use a tool called convert trips. The input will be this OD matrix. And another one is called trip time. This is very easy to understand. So it has a start and end, which indicate 2 time points. And the shell means the relative proportion of the trips happening. For example, if I have 8, 9, 1 and 9, 10, 2, this will indicate there are 2/3 trips happening between 9 o'clock and 10 o'clock, and 1/3 of them are happening between 8 o'clock and 9 o'clock. Okay? But in this way, we're just, in today's demo, I just use one line, which specifies between 8 o'clock and 9 o'clock, the share is 100%. Then if I run the convert trips tool, then it's done. You will see here the total number of trips read, 400, and total number of trips written, 400, and it's completed. Okay, it's very simple. Then in the output folder, we are going to see 4 pairs of files. The first one is called household. So Transits synthesize a lot of household. In each household, we have persons, and we have some kind of vehicles. This file is not used later. The important file is called trip.csv. Let's check this. So in this trip file, each record is indicating a certain trip between a certain activity location and another activity location. So let me read this and let me explain this to you. So this is a person, the number 1 person, the first person in household 1. And this is its first trip. It has a purpose, it has a mode, and it's going to use this vehicle with ID 1. This trip happens at 8:32 from an activity location with an ID 15. And it arrives at this time. It's estimated that it will arrive at 8:44 at activity location 22. And that's it. So when to start, where it starts, and where it's destined. Another file is called vehicle.csv, and here you will be able to see the vehicles that are used by each traveler. So this vehicle ID 1 is belonging to household 1, and it's parked at location 15, activity location 15, and it has type 1 and subtype 0. These 2 things are defining the characteristics of the vehicle, and we have to check another file called vehicle type to see the detail. But now we can just ignore this and go to the next step. So we have already generated 2 important files: trip and vehicles. Then the next step will be to run it, called route planner or router. In router file, we need to specify a lot of input files, as I already put here. So node, link, connectivity, parking, these things are generated. All these are generated by the tool called TransImsNet we just used. And these two are generated by convert trips. And we are ready. The output of router is plan file. And this router is doing trip assignment. So in the last trip file, we see the origin and the destination, but we don't know which links the traveler will be using. And that's why we use the router. And we run it, and it's done. In the output folder, we're going to see a file called plan.txt. This file is not named as plan.csv because plan files cannot be created in that way. And these are things that are very difficult to understand. But you can check the files. You can check the document I provided in the DOC folder. There is a folder called TransIms Fundamental. If you go to TransIms Fundamental and go to chapter 5, you are going to see the whole explanation of router. And you will be able to see the explanation of the plan files. So what is the plan? So this is a plan. So in TransIms, we have several layers. Each layer is representing a travel mode. And a plan is the path of a traveler from one location to another by going through, by traveling between these layers and on these layers. So any link between layers are called process links. Okay? So for example, if I go to the parking lot, I walk from the building to the parking lot, I'm going through a process link. Then when I drive on the road, I will be driving on one layer. Then I will be driving on the link. And the plan file is a detailed path generated. So in the beginning, we have origin and destination. Then after the router, we have the path. Starting from step 6, we don't need to understand its algorithm because it's not a focus of today. We'll just focus about a network. We'll focus on a network. So I just run a router and we get the output. The next step is called plan preparation. And it's simply sorting the output, sorting the plans. So if we get a plan from the last step, we just run it here. And the plans will be sorted by their starting time. Okay. And the next step will be micro simulator. And this is the part, the most essential part to simulate the movement of vehicles. In micro simulator, we have to supplement these things: node, link, parking lane, and link connectivity, and these things. And other than that, we have to provide a sorted plan, which is created by the last step, and vehicle.csv, which is created by convert trips. And there's one file missing called vehicle type. In vehicle type, we have the maximum velocity, maximum acceleration, the length, capacity, which means how many people can sit in a vehicle, and an attribute called never lost. So sometimes when the network is too congested, some vehicles may be removed from the network. But if it's claiming never lost, then it will not be removed, I guess. So here's vehicle type and subtype. And in our result, if you remember from convert trips, all the vehicles, all the chips are using vehicle type 1 and vehicle subtype 1. So I'm just defining these attributes. For example, this is maximum velocity, which is equal to 37.5 meters per second. And the length of the vehicle is defined as 7.5 meters. All of these things are metric using the metric system. So this is why I have to supplement in the micro simulation stage. And other inputs are created from last steps, previous steps. And if I run it, and you will see completed. You will see it completed. The number of trips processed is equal to 400, but only 354 of them are processed. And there are 33 of them having problems. And the reason that they have problems is that they don't have any, there is no no route between the OD, between the origin destinations. And you can ignore this at this time. But the process has been completed. The output of micro simulator can be many, but here in my control file, I only specify 2 outputs. One called a snapshot. In the snapshot, it's recording the vehicle's speed, acceleration, and location at each time step. Okay? So this is the first vehicle, and at this time, the unit is second. It's existing, it's located at link 5, link 3, and offset 862 meters. And here's its speed and acceleration. Okay, so these are the snapshots of the simulation. We can visualize later. Another file is called performance.csv. In this file, you will be able to see the performance of links, the aggregate performance of each link. So, for example, here is link 1, direction 0, one direction, AB, and it has average volume